Hello, let me briefly explain today's assignment, which is on shortest path in directed graphs. Okay, so this graph shows the connectivity of some cities, number 0, 3 and -1 by flights. So we government employees for official work need to take only Air India AI flights. Okay. So these AI flights are shown by these red edges. From city 0 to city 3, there is an Air India flight whose cost is something like 92, maybe 9200 or something like that. But some cities are not connected by Air India flights. For example, from 1 to 4, a non-Air India flight, maybe Jet Airways or Indigo, this operates from 1 to 4. And this cost is something like 76. So non-AI flights are shown by blue directed edges, and the ticket prices are shown against each edge. Okay. So for the purpose of reimbursement, suppose I want to move from 3 to 4, so I have a flight here. Of course, here I cannot go, but if some red edge is there, then this path, and if there is a direct flight, whatever the cost of this is, if this cost is larger than this plus this, then we would prefer this. Sorry, which is larger? This is larger than this plus this, so we will take this. For the purpose of reimbursement, the route should be as cheap as possible, even if the number of legs increases. So these are direct flights, non-stop flights. Suppose I want to go from 0 to 2, so I have to come here and here. The total price is 92 plus 91. Okay, so this graph specifies the connectivity, direct connectivity of flights by AI and non-AI airlines. Okay. Now, since the question of AI travel is important, we first construct one thing. Consider only the AI edges that connect different cities. And then you run Floyd-Warshall algorithm on this subgraph to find out which travels are possible and what is the cheapest alternative. Okay. Of course, in this case, this example, this is a very small example. If a pair of cities is connected, it is connected in a unique way, or else it is not connected. But suppose if I had another edge 0 to 2, then I have to compare this plus this with this cost. Whichever is smaller, that will be my shortest path. So if you run Floyd-Warshall algorithm for all pair shortest paths, you find out complete Air India connectivity. Okay. But you see that there are several troubles. Air India, for example, cannot connect 4 to 2. Okay. So in that case, if you are allowed to use non-AI travels, non-AI legs, then possibly you can connect cities that are the routes that are not serviced by AI. So here is an example. So there are two ways you need to handle this. From each city to each city which is not served by Air India, you are allowed to make only one non-AI leg. Okay. So for example, if I add this single leg 420, then I discover, it is given here, I discover 2 4 to 2 paths. One is like this 4 0 5 3 2, another one is 4 3 2. Okay. And it turns out that the 40532 costs something like 236, whereas 4032 path costs 204. Why 204? 402. Okay. So this is 21 4032 plus 92 plus 91. Yeah, that comes up to be 204. Okay. So you have to take that path. So in the second part, you are allowed to use only one non-AI leg in order to connect pairs of cities, provided that these cities are not already connected by Air India. So this is your part 2. So one possible way of solving this problem is, one by one, pick one edge, blue edge from here, as I have done here. I have picked this edge, 40 edge, costing 21. And once again run a PSP on this. Okay. Now because only one edge is added, so it is not possible for a route to contain multiple blue edges. That's impossible, right? However, the introduction of this blue edge may reduce the cost of some city-to-city travel, which is already handled by AI. That is not allowed. Okay. But anyway, if you are given a chart from this and the chart from this, you update that chart only when this chart contains something like infinity. Okay, it's not serviced by AI, but now you have a service from city 4 to city 0, whatever the cost, store it. But this algorithm is not very good because there may be O(n) square, big O of n square blue edges in the graph, and each Floyd-Warshall takes big O of n cube time. Okay, so the total running time may be as bad as n power 5. But you can solve this problem in big O of n power 4 time. Okay, this is as follows. So from this chart, you pick some I, j like 4, 2, which are not serviced by Air India. 4 to 2, there is no Air India route. Okay. So now you look at these edges one by one. Okay. There are n square such pairs, maximum, which are not connected by Air India. Okay. And there are n square such edge. Now pick each one of this edge. So from I, let us call it I, let us call it J, let us call it K, let us call it L. Okay. And then you find out whether you can go from I to K using Air India. Then you take that edge K to L, and then you see whether you can go from L to your final destination J by Air India. If so, you modify the cost, but additions of different blue edges may lead to different paths from I to J. So you have to minimize over all these edges K, L. So as this example suggests, you may have I equal to K or J equal to L, or maybe both. Okay. So take care of this. And in the final part, if you are allowed to use any number of blue edges, provided again that service, that route like 4 to 2 does not have an AI service, AI only service. So in the third part, what you will have to do, now if 4 to 2 is not serviced, I can do something like this. I can come 4 to 0, 0 to 5, and then 5 to 2. And earlier best cost was 204 as I mentioned. Now it is 21 plus 95 plus 76, which turns out to be 48, which turns out to be 164, which is even smaller than 204. Okay. So these three charts you need to prepare. AI only plus only one allowed non-AI leg, and an arbitrary number of non-AI legs, which is part 3. Okay. And in all cases, if Air India serves something like 0 to or maybe 0 to 2, you have to use that. even if using blue edges reduces the cost. Okay, in all the parts. Okay. So, how to do this in the third case, allowing multiple blue edges? This algorithm will leave it to you. It's fairly straightforward. You will design a ON cube type algorithm. And for the second part, allowing single edges, I have proposed on n power 4 algorithm. I am not sure whether an ON cube type algorithm can be used for this part. So, if you have any idea, please let me know. As of now, I do not know whether it's solvable in ON cube type. ON power 4 is fine. Okay. So, how do you store such a graph? So, we recommend using something like a adjacency matrix representation. This is no longer adjacency list, it's adjacency matrix. So, if there are n cities, you maintain two n by n arrays. One array is for storing the information of the airline, that may be a character array, and the other array for storing the price. Incidentally, you do not have multiple edges. If you have a blue edge between two cities, this is only one edge. If you have the red edge, this is only one red edge. It's not like that we have red edge here, another blue edge here. It's not like that. Okay, fine. So, in that character array, if it is a red edge, you store, let's say A, standing for AI. If it is a blue edge, store N, standing for non-AI. If there is no connection, direct connection from, let's say, like 0 to 1, store something like minus, non-existent, something like that, minus. And if I look at I comma j, I equal to j, then of course you don't need to travel by flight from 1 to 1, for example. You just store something like S, stay. Okay. And in the other array is the cost array. Once again an n by n array, but this time of integers. You simply store this cost. If that age is not there, store infinity. And if it is same node 1 to 1, you store 0. Okay. And from this graph, generate this AI subgraph, which is exactly in the same format. Run this APSP algorithm on this AI graph to prepare your first chart, and then you prepare your second chart by allowing single blue edges. For that matter, you follow the algorithm that I recommended, or for that matter any better algorithm like a ON cube algorithm that you may come up with. And for the third part, allowing multiple edges, multiple blue edges, provided that root does not have AI service. Okay, so this is briefly today's assignment. Let me quickly browse through the text. I hope this picture makes clear what you need to do. First, the graph data type is adjacency matrix, number of cities, n by n array of operator airlines, n by n array of integers storing the ticket prices, and I use that convention A for AI, N for non-AI, minus for no flight, and if I equal to J, just say stay put, and store the cost. If I not equal to J and there is no flight, store plus infinity as the ticket price. If I equal to J, store 0 as the ticket price. And like in the previous assignment, you write a function read graph to read the graphs, this graph by user inputs. The user first enters n, then a set of quadruples I, source city, destination city, the cost, and the type of airline, AI or non-AI, A or N. And whenever -1 is supplied as I, stop. And part 2, from that full graph, you build only the AI graph, that is a graph consisting of all the vertices but only the red edges. This is this graph. and write a function to implement APSP to implement the Floyd-Warshall all pair shortest path algorithm. And when you run that or invoke that function on this graph H, you will get your first chart C1. And then APSP with one non-AI leg allowed, provided that. So the second chart, look at the entries of C1 that are less than infinity. This is indicating AI connectivity. Then you do not change that thing in C2, the second chart. Only when if it's infinity, you follow this algorithm. Like go from I to K via chart 1, then take the K to L flight, which is a blue flight, non-Air India flight. Then once again from L to J by Air India, that is available from part of this chart C1. And minimize over all possible non-AI flights K, L. It is allowed to have I equal to K or L equal to J or both. So take care. And finally, the third chart, if AI already provides an I to J service, you keep C3ij equal to C1ij. Other than that, otherwise, if it is infinity, you allow multiple number of non-AI legs and find out what happens. So another example here that I forgot to mention is that if I look at 1 to 0, AI does not provide any service from 1 to 0. If you allow only one blue leg, then also you cannot connect 1 to 0. Only when you allow two blue edges, 1 to 4 and then 4 to 0, then you can connect 1 to 2, 0, 1 to 0. Okay. So write this function and design this algorithm. It should run in big O of n cube time. Okay. So called read graph, get AI graph, APSP on H, then APSP1 for this, APSP any for this. And in this assignment, it suffices to compute only the cheapest flight prices for different sectors. No need to actually prepare the cheapest routes, like cheapest 4 to 2 routes in the last cases we have seen. This is 4, 0, 5. You do not have to store this route. Only compute the minimum cost. Don't make an attempt to store the actual minimum cost cheapest routes. If you want, you can do it the take-home assignment, but you do not have to submit it. And this is once again the IO format: number of vertices, source city, destination city, cost, and whether it's an Air India flight or a non-Air India flight. Then print the graph, get the I graph and print it, and cheapest AI prices. This is your chart 1. Minus means this is not served by AI. And cheapest price with at most one non-AI leg. So this is this, and cheapest price with any number of non-AI legs, provided that Air India does not solve that pair I to J. So for example, if I look at 4 to 2, we talked a lot about that. Air India does not provide any service. 4 to 2, this is 20381. I told 204 because the picture costs are the scaled down version of this. And if you allow multiple legs, this 4 to 2 becomes 164, 16441, something like that. Okay, so that's all. I believe it's good enough. I will start coding. I hope today's assignment is much easier than last week's assignment, and we will be online, and we will send you a query link for sending your queries, a form, a Google form for sending your queries. And again, try to send your queries there instead of individually mailing to us. It's difficult for us to answer individual queries, particularly when these individual queries come in large numbers. And there will be a fact file, so you keep on looking it from time to time. So after posting your query, you maybe wait for 5 to 10 minutes. We will give an answer there. Fine. So carry on. Go ahead with your solution. So see you.